Friends, in previous topic we discussed how to insert the rational numbers between the rational numbers and the integers, and how to represent the rational numbers on the number line, and what is the difference for the rational number and fraction numbers. So now today in this topic we are going to discuss how to change the rational numbers into decimal form. So rational numbers are terminating decimals or the non-terminating decimals. So we can express the rational numbers in two forms of decimals. They are the terminating decimals and non-terminating and recurring decimals. We can change the rational numbers into decimal form. Here decimal form we can express the rational number in the decimal form as terminating decimals or non-terminating and recurring decimals. Terminating decimals, non-terminating and recurring decimals. So, terminating decimals and non-terminating decimals and recurring decimals. Let us take some examples. So, we know that one fraction form of numbers are the rational numbers. Like we will take 1 by 4, 2 by 3, 5 by 8 by 5, 11 by 2. Some fractions we took. In these fractions, which are the terminating fractions and which are non-terminating and recurring? Terminating means there is a end. Means the division completes with the remainder 0. That such type of fractions are called terminating. Next, some fractions the division does not end and the quotient will repeat continuously the same number. Such type of fractions are called non-terminating and recurring decimals. So here we took 1 by 4, 2 by 3, 8 by 5, 11 by 2. Let us check out in this which are the terminating and which are non-terminating and recurring decimals. So when we change the rational number into decimal form, so we know that one, this is the numerator, 1 is the numerator, 4 is the denominator. 2 is the numerator, 3 is the denominator, 8 is the numerator, 5 is the denominator, and here 11 is the numerator and 2 is the denominator. So every time we should divide the numerator with the denominator. Numerator should be divided by denominator. Okay, let us divide 1 with 4. So 4. 1 does not divisible by 4. So we should take a decimal point. When you take the decimal, we can take 1 0 in the dividend part. Now the dividend is 10. In 4 table, 4 divides the, so nearly 2 times. 4 2s 8. 10 minus 8, 2. Here we have decimal. That's why every time we can take 1 0. Take down 1 0. Now the dividend is 20. 4 divides the 25 times. 4 5s are 20. The remainder is 0. When the remainder is 0, the division is finished. When division completes, such type of decimal is known as terminating decimal. So the rational number 1 by 4 is a terminating decimal. Let us see. 2 by 3. 2 by 3. 2 should be divided by 3. 2 is smaller than 3. It doesn't divide. Therefore, we will take a decimal point. Will come 20. 3 divides 20. 6. 3 6s 18. 20 minus 18, 2 comes. Again, the decimal place point is there, that's why we can take every time 1 0. 3 6 are 18. Again, 2 comes. So, again 1 0, 20. Again 6 are 18. 3 6 are 18. Again 2 comes. So, the division is continuously going on. Okay. So, now the remainder is 2. The remainder is 2 here. It's not a 0. So, that's why the division not finished. So, that's why, and the if we see the quotient is also repeating the same number. So, the division not finished, completed, and also quotient is repeating. That's why we can call this as non-terminating. Non-terminating means no end. The division does not end. The remainder never be 0. Okay. So, non-terminating. The remainder never be 0 here. So, that's why it is non-terminating. There is no end for the division. And recurring. Recurring means continuation. The quotient will repeat. Continuously repeat the same number. So, here 6 is repeating continuously. So, more number of times. How many times will take the division? That many times the 6 will repeat like anything. So, that's why. So, it is non-terminating and also repeating. So, that's why. So, this type of decimals are known as non-terminating and recurring decimals. Therefore, 2 by 3 is non-terminating and recurring decimal. This is terminating decimal. Here 1 by 4 value is 0.25. Right. 0.25. So, it is a terminating decimal. Next, 2 by 3 value is 0.666 and so on. So, we can represent this one as 0.6 bar. So, a number under the bar is there means the number is repeating continuously. So, 6 is repeating infinite number of times. So, that's why instead of writing many times, they simply represent 0.6 bar. Means under the bar the number whatever it is there that repeats continuously. So, it is non-terminating and recurring decimal. Let us check out rest 2. 8 by 5. 8 should be divided by 5. 8 is bigger than 5. So, in the 5 table, 5 ones, 5. 8 minus 5. 3 comes. 3 is smaller than 5. So, take the decimal point. When we take the decimal, whenever the dividend value is smaller than the divisor, then we will take the decimal. If there is no dividend, any other value is not there in the dividend, then we take the decimal. Okay. So, 30 in 5 table. 5 6s 30. Remainder is 0. So, the division completed. The remainder is 0. So, then what we can, quotient does not repeat. It is star. Division is finished. So, what type of decimal it is? Terminating decimal. What is the value of 8 by 5? 1.6. Right here. 1.6 and it is terminating decimal. And let us check out 11 by 2. 11 divided by 2. 2 5s 10. 11 minus 10, 1. 1 is smaller than 2. So, take the decimal point. This becomes 10. Again, 2 5s, 10. 0. Division, cut, end. The remainder is here, 0. Therefore, it is a terminating decimal. The value is 5.5. So, these three, 1 by 4, 8 by 5, 11 by 2 are the terminating decimals. 2 by 3 is non-terminating and it is a repeating decimal. Let us take one more example. Hmm, 13 by 20. 13 by 20. So 13 division with 20. So 13 is smaller than 20. Take decimal 130. 20 6 are 120. 10 comes. Here decimal is there, that's why decimal point is there, that's why we can take 1 0. 5 are 100. 0. So it is also a terminating decimal. 13 by 20 is terminating decimal. The value is 0.65. Let us take one more. $22 by 6. Okay, 25 by 6 will take. 25 by 6. 25 division with 6. 6 fours 24. Minus 1. 1 is smaller. That's why, sorry. One decimal point we took. The value is 0 here. So the value is now 10. 6 table 10. Nearly 6 ones 6. 4 comes. Again 0 we can take because we have kept one decimal point in the quotient part. 40. Again 6. 6 are 36. 36. Again 4 comes. Again 40. Again 6 6 are 36. Again 4 comes. So we can observe 25 by 6 is a non-terminating and recurring decimal. The remainder is here 4. Every time we are getting the remainder 4. So that's why it is non-terminating and recurring decimal. So what is the quotient? 4.166 and so on. Yeah. If we see here 1 by 4 is terminating. 8 by 5 is terminating. 11 by 2 is terminating. 13 by 20 is terminating. 25 by 6 is non-terminating and recurring. Here 2 by 3 also non-terminating and recurring. Now we are identifying this, they are terminating or non-terminating by taking the division, long division method. But we can identify the given numbers, rational numbers are terminating or non-terminating without doing the division. Without actual division we can identify. So what is here means, if we see first one, there is a 4. 4 can be written as 2 into 2. So the factors are here 2 into 2. Next here 5. Okay, it is also terminating. It is 2 is there. It is terminating. 20. 20 if you split out into prime factors, 2 tens are, 2 5s are. So we can write it as 20 denominator as 13 by 2 square into 5 or 2 into 2 into 5. 5. 25 by 6. Take the denominator, 2s are. 25 by 3 into 2. If you observe here 1 by 4, the denominator, everywhere we are splitting the denominator into their prime factors. So 4 prime factors, 2 2s are 4. Split it into prime factors, 2 into 2. Here 2 by 3. So it got split out. Here 5 we can't split out, 5 as it is. 2 we can't split out, 2 as it is. 20 are splitted as 2 into 2 into 5. And 25 by 6 is splitted as 3 into 6. From here, if we observe, whenever the denominator is the factors 2's, only 2's or only 5's, only 2's or 2's and 5's, the time that rational number is terminating. So that decimal is terminating decimal. So here 1 by 4. Here 1 by 4 is 1 by 2 into 2. Okay. So the denominator, numerator, don't split the numerator. Just take numerator as it is. Only denominator we have to split out into its prime factors. So 4 can be written as 2 into 2. So the denominator has two factors. Prime factors 2. Similarly, 8 by 5. It has denominator 5 factors. Only 5's. And if you see another one, 11 by 2, it has the factors only 2. Prime factor 2. And next one, 13 by 20, 2 into 2 into 5. So, 2's and 5's. Denominator is splitted as the prime factors 2's and 5's. So, it is also a terminating. So, whenever in the rational number which we can say whether it is a terminating or not by splitting its denominator into the prime factors. If the prime factors are only 2's or only 5's or combination of 2's and 5's, then that is known as terminating decimal. That number is called terminating decimal. So, a rational number, we can say it is a terminating if the denominator can be written as prime factors of 2's or 5's or both, then that is known as terminating decimal. If we see in the second case, 3 is the denominator. It is not 2, it is not 5. So, instead of 2's and 5's, any other number is there, means it is a non-terminating. So, 3 is there. It's not a 2's and 5's. That's why it is a non-terminating. And similarly, if you come to this one, 25 by 6. Here, 3 and 6 are the factors. The condition is what? It should be either only 2's or only 5's or 2's and 5's. But here, 2 is there of course, but 3 also there. That's why it is not a terminating. Then it is known as non-terminating and recurring decimal. Okay, let us see some more examples. (17 by 50). 37 by 15. 49 by 60. Some numbers. Let us check these are the terminating or not. So first denominator. We have to see only denominators. So 50 split into their prime factors. 5 tens are, 5 twos are. So we can write it as 5 into 5 into 2. 17 by 5 into 5 into 2. Next, 37 by 15 split out into prime factors. 3 5s are 3 into 5. Next, 49 by 60. 49 by 60. Split into factors. 2 30s, 2 15s, 5 3s. 2 into 5 into 3. Now let us check out which are the terminating, which are non-terminating. 17 by 50. We can say it is a terminating. Why? Because the denominator is written as prime factors of 2's and 5's. So our condition is must be either 2's or only 5's or both. So instead of this one any other number is there means it's not a terminating. So that's why this is a terminating. Here 37 by 15. So denominator is split as 3 into 5. 5 is there, but additionally here 3 also there. So that's why the condition not satisfied. It must be either 2's or 5's and 2's and 5's. But here 3 is there. That's why it is non-terminating. So it is not a terminating. We can say it is non-terminating. It is terminating. And here also if you observe 2's are there, 5's also there. But additionally here 3 also there. So it is also not terminating. So we can say it is a non-terminating and recurring decimal. So instead of 2's and 5, any other number is there in the denominator. Those are non-terminating only. Okay.